Hello, I'm Ryan with High Desert Math Tutor, and today I want to take a moment to talk to you about similar triangles and similar shapes or proportional shapes in general. So the purpose of me talking to you today is to show you a different approach than what's commonly taught in many schools for finding what's called the scale factor between two similar or proportional shapes, and also solving for unknown sides on proportional or similar shapes. So before we jump into just solving this the way that I commonly solve problems like this, I want to just make sure we have some common ground with definitions. So when we talk about similar or proportional shapes, what we mean is similar or proportional shapes are the same in every way except for possibly the size. So all angles inside similar shapes are the same angles. Ratios, so like if you look at how big this side is compared to this side, would be the same as how big this side is compared to that side. Now another thing to talk about is scale, which what scale is the size of something, but often when we're talking about scale, we're talking about the size comparison between two different shapes. A scale factor is what our focus today will be, but a scale factor is how many times bigger one item or one shape is compared to another item or shape. And usually when we're talking about scale factors, we're talking about the size difference going from one shape to another shape. And finally, and this is a big component of the way I deal with proportional triangles or similar shapes, is talking about correspondence or corresponding sides. So what corresponding sides are, they're sides on a shape between two shapes that play the same role. So if we're looking at this side of this triangle, this is the shortest side of this triangle. The side on that triangle that corresponds to this is the shortest side on this triangle. The longest side on this triangle is 5. The longest side on this triangle is 30. So since these sides are each the longest sides, they correspond to each other. So now the quick and easy way that I solve for unknown sides on similar shapes. First, you pick two corresponding sides. So I'm going to go ahead and focus on the longest side of each of these triangles. So the longest side, since these are each right triangles, will be the hypotenuse. And what we do is I'm going to go from the smaller triangle to the larger triangle. So I'm going to ask, what do you multiply this 5 by, the longest side by? What do you multiply that by so that it turns in to the longest side on this triangle? So I just gave this unknown value the name k, but what k actually stands for in this context is our scale factor. So this represents how many times larger this side is than this side. So all we have to do is get k by itself, and we'll know how much larger this triangle is compared to this one. So 5 times k equals 30. If we want to get k by itself, we get the 5 to go away by undoing what's currently happening. Since we're multiplying by 5, the opposite of multiplying by 5 is dividing by 5. So these will cancel, but whatever you do to one side of an equation, you have to do to the other. So we divide by 5 on that side also. All that's left over here is k, and 30 divided by 5 is 6. So what this tells us is that this triangle, the length of each side is 6 times larger than the lengths of the sides on this triangle. But these two triangles are proportional. So the only thing that's different between the two of them are the lengths of the sides. So now just to check our work really fast to show that this value can help us find the other sides on this triangle, let's test this scale factor with the smallest side of the triangle. So we'll say 3 times the scale factor. That's the same as 3 times that scale factor over there is 6. And 3 times 6 is 18. So see, if we multiply the shortest side, 3, on the small triangle by our scale factor, it turns this side into the length of the corresponding side on the longer triangle. So now, we can use this information to solve for our unknown side over there. So the side we do know, on our small triangle, the length is 4. And if we multiply 4 by the scale factor 6, that's going to turn this side into the equivalent side on the larger triangle. Well, 4 times 6 is 24, which means our unknown value is 24. So this is another approach to solving similar or proportional shapes, specifically in this case, proportional triangles. Now, the benefit to this approach is when you get used to looking at these corresponding sides, you can pretty quickly ask yourself, what do I multiply 3 by to turn it into 18? And you may say, oh, I just multiply by 6. And just like that, in your head, you would have already found our scale factor. And then again, in your head, you could actually ask, okay, well, this side corresponds to the unknown side on the other triangle. So if I multiply this side by 6, I get 24. So it's a nice, fast way for solving for unknown sides on proportional or similar shapes.